This is section 2.3, solving linear equations involving fractions and decimals, and you're also going to be classifying equations. So here's number one. We're going to continue using the idea of undoing what was done, the idea of opposites. So before I begin with this problem, I notice that I have some denominators 2, 11, and 22. What I'm going to do is first I am going to find the LCD of those three denominators, and you're going to see why. So once I do that, I am going to make whatever's not a 22 into a 22. That's why I did not multiply this fraction by anything. So once I simplify the products, this is what I get. 33 over 22x, 8 minus 8 over 22 equals that. Then at this point, I am going to do the following. I am noticing that I'm dividing every single denominator here on the left side and the right side by 22. So I am going to do that division by a multiplication on the left side of 22 and on the right side also multiply by 22. So once I do that, notice in this on the right hand side, you just get 91. And then when you distribute the 22s here, these cancel. And then I'm left with just 33x minus 8 equals 91. And then continue with the idea of undoing or opposites. They're adding 8. They're subtracting 8. So I am going to add 8 to both sides. Simplify. They're multiplying both sides by they're multiplying by 33. So I am going to divide both sides by 33. And then my answer is x equals 3, or I can use the set notation. Let's go to number 2. So this one's a little bit different. Now notice that this equation involves decimals. But the way that we're going to take care of this problem, first you need to notice that this has one decimal place, this has two decimal places, 1 and 1. I am going to highlight the term that has the most decimal places, which is this one. I notice that I have two decimal places, so this is what I'm going to do. I am going to multiply both sides of the equation by 100. By 100 because it has two decimal places. If we had three decimal places, I would multiply by 1,000. Once I multiply both sides by, in this case, 100, this is what you get. 100 times 0.5m becomes 50, and you should be able to follow the rest. At this point, I noticed that what they did is they separated these two terms, so I'm going to combine them. Do the opposite. And then I get 15m. 15m equals 250m plus 940. Next thing that I'm going to do is I am going to, they're adding 250m, so I am going to subtract 250m from both sides. Once I do that, these go away, and I'm left with whatever this is, which is exactly negative 235m equals 940. At this point, they're multiplying, so I am going to divide by negative 235. Once I take care of this division, I have a positive and a negative. You pull out the calculator and you divide, and you end up with m equals negative 4. Let's go to the next slide. So more decimals. Here, notice that you have the decimals on the left-hand side and right-hand side outside of parentheses. What I'm going to do here is I'm actually going to apply this distributive property. Once I do that, you should be able to follow this. Is this negative 0.2w plus 0.8, y positive here, y plus, because negative times negative is positive, and you should be able to follow how I get this binomial, or these two terms, on the right-hand side. Now at this point, I notice that every single one has a 1 decimal place, so I am going to multiply both sides of this equation by 100. So once I do that, I multiply both sides by 10, then, excuse me, this is what I get. This becomes negative 2w plus 8. The right hand side becomes 18w minus 12. And then at this point, I am going to undo what they did. It looks like they took away 2w from both sides, so I am going to add 2w on both sides. These go away. This is going to become 20w. To solve for w, it looks like they took away 12, so I'm going to add 12 both sides. This goes away. I end up with 20 equals 20w. Divide both sides by 20 because they are multiplying here. The opposite of multiplication is division. And I end up with w equals 1, or I can use the same notation. Let's go to the next problem. The directions change a little bit different. You're still solving the equation. That's the first part. The second part, it says state whether the equation is a contradiction, an identity, or a conditional equation. We'll worry about those once we have something in front of us. So I'm basically going to start solving the equation, and we'll see what happens. So I notice that I have fractions. I don't like fractions, so I can write a 1 underneath here. And I am going to look for the least common denominator of these four numbers. It turns out to be 12. So I'm going to go here, and I'm going to make sure that every single denominator becomes a 12. So I multiply top and bottom by 12, top and bottom by 4, top and bottom by 3, and notice that I include a parenthesis here. And then top and bottom by 2. Once I do that, I am going to clean it up a little bit. Notice that this becomes negative 12 over 12. This becomes 4x over 12. I distribute the 3 into these two terms here using the distributive property, and I get 6x plus 3. 4 times 3 is 12. Bring down the sign. X times 2 is 2x. 6 times 2 is 12. I notice that every single denominator now has 12. So I'm dividing everything by 12. How do I undo that division of 12? I do a multiplication of 12 on both sides. So once I multiply both sides by 12, it's going to eliminate all the denominators. And I'm basically going to be left with whatever's in the numerators on both sides, which turns out to be the following. And then at this point, I'm going to begin to undo what they did. They say, if I go to the right-hand side, I'm going to have to, they separated the x's, so I'm going to combine the x's. That gives me 4x. Then I am going to undo this addition of 4x on both sides. And so these will go away, these will go away. And notice that this is going to be a little bit interesting. And this pertains to the second part of the problem. And I'm going to end up with negative 12 equals 3. And this should not make any sense to you. Negative 12 is never equal to positive 3. So that's why, in this case, there's no solution. It's an empty set. So you write this, you use this notation, these brackets, and you don't put anything inside. That means that there's no answer in this problem. And then for the second part, this is what we call a contradiction, because this is never true. Negative 12 is never equal to positive 3. So you write contradiction. So let's go on to number 5. So again, first part is basically to solve the equation, and then the second part, we're going to determine if it is contradiction, identity, or a conditional equation. I'm going to distribute the 2 on the right hand side here, and I end up with 2x minus 2, and then I am going to combine these two, negative 2 and 6, which gives me 4. And notice that what I get here is 2x equals 2x, and this is always true. The left side is always equal to the right side. If you want to go take it a step further and take away 2x from both sides, notice that you're going to get, if you take away, if you take away 2x from both sides, you're going to end up with 4 equals 4. And this is always true. So what is the solution to the equation? In this case, when you get something that makes sense like that, the answer is all real numbers. That is the first part. And then for the second part, this is what we call an identity, because the left side is identical to the right hand side. So this is one very easy way to remember that this is what we call an identity. Let's go on to the last problem in this video. So here's number 6. Again, 2 parts: solve the equation and then state what it is. So what I'm going to do, I notice that I have 2 denominators, 6 and 4. I'm going to look for the LCD of 4 and 6, which turns out to be 12. So I'm going to make every single denominator a 12. So I multiply top and bottom by 2 on the left hand side, top and bottom by 3 on the right hand side. 6 times 2 is 12, 4 times 3 is 12, and then I leave this just the way it is. My next step is basically to distribute, and this is what I get on my numerators without the parentheses. And again, on both sides I am dividing by 12. So what am I going to do to undo that division of 12 is to multiply both sides by 12. Once I do that, this goes away, and I'm left with just the numerators. And I basically undo this equation. It looks like they added 9 here, 9n, so I'm going to take away 9n on both sides. So this gets rid of that, equals negative 6 on the right hand side. 10n minus 9n is n. And then I am going to undo this subtraction of 2. So I'm going to add 2 to both sides. And I end up with n equals negative 4. That is the answer to the first part. Now I need to state what it is. And in this case, when we actually get a solution, we call this a conditional equation. This concludes the video. Again, in class, if any part of the video any problem on the video did not make sense, you can just ask me to clarify it in class.